What do Brazilian samba, West African drumming, and neutron accelerators have in common? Well, they all rely on Euclidean rhythms. A Euclidean rhythm evenly distributes k pulses into n steps, and the algorithm behind it was developed for the timing system of the particle accelerator at Oak Ridge National Labs before a McGill researcher realized it described folk rhythms from dozens of cultures worldwide. This project lives in the world of Eurorack modular synthesis, a format started in 1996 that's grown into an ecosystem of over 15,000 modules from more than 600 manufacturers. Eurorack systems range from briefcase-sized performance rigs to room-filling walls of gear. The goal here was to fill a gap in the existing market with a Euclidean sequencer specifically designed for live performance. Most Euclidean sequencers give you 1 or 2 patterns with a fixed length. This design goes further, 3 independent banks, each with 3 patterns driven by an internal clock. Each bank shares a common length, but has individual patterns with independent step count and offset. Crucially, every bank includes a sum output, a logical OR of all 3 patterns, that produces complex composite rhythms that no single Euclidean pattern could generate alone. The sum output makes this design novel, as no surveyed competitors currently include this feature. The module runs on an STM32 microcontroller, the industry standard for synth hardware. The sequencer algorithm uses a Bresenham-style accumulator to compute up to a 64-step bit mask in real time. Timing is handled by hardware PWM timers to minimize jitter. Rotary encoders control the tempo, pattern length, steps, and offset, with a shift function doubling each encoder's capability. This design has no menus and no control voltage. Every parameter is a single knob turn, keeping decision fatigue low during live performances. Looking at the competitive landscape, existing modules like the VPME Euclidean Circles and Rebel Tech Stoicheia top out at 6 channels and 16 steps, with prices ranging from $180 to $350. As this design offers 9 channels, up to 64 steps with an internal clock and the unique sum output, the target price is around $400. The synthesizer market was valued at $1.34 billion in 2025 and is growing steadily, and Euclidean sequencers are a well-established category with clear demand. This proof of concept design is limited to 1 bank and 2 patterns due to on-campus PCB manufacturing constraints. The full 3-bank version will use STM32 G-series microcontrollers, 1 for each bank to handle the 4 encoders, and finally 1 to create the gates, which will all be connected over SPI or I2C. An expander module with XOR and AND functions is also planned, further expanding rhythmic possibilities with minimal hardware.